Hi, welcome to the video. My name is Pushpinder Gill, and today we are going to do Inequalities 2. So before starting the video, so this is our Facebook page, facebook.com/perfectscores. Don't forget to like us on this page, show your support, and this is my email address, that is perfectscores89@gmail.com, where you can send me your valuable feedback, right? So in case you want to explore more about Perfect Scores, so this is the web address, that is perfect-scores.com, where you can explore about perfect scores. So today we're going to do inequalities part 2, wherein I actually teach the method which is called the column method, right? So which is a great technique when it comes to inequalities in GMAT, right? So this is actually something really great. So this is applicable in GMAT and in CAT, right? Both the exams. So in case you're planning to watch this video and this is the first video on your perfect scores, so I would actually recommend you to watch the data sufficiency 2 video, that is the yes no data sufficiency. You should be pretty much equipped with this technique, and the next thing that I would want you to watch is the inequality video 1, right? So that is something which is a prerequisite for this video. So let's go ahead and get started with that, right? So the column method. Now what exactly is column method? Before I apply it to a question, I would actually want to give you the overview. Now what happens is, when it comes to inequalities in GMAT, the question actually asks us to exhaust all the possibilities, to see all the possible combinations. So if you want to exhaust all the possibilities, the column method comes into place. So let's see how do we do that, right? So that is the basic thing for column method is that we have to work in columns, right? So working in columns and exhausting all the possibility will make sure that we go ahead and get the answer in a really structured manner, and we will definitely get the answer here, right? So one thing that I want to emphasize over here, let's suppose you have 37 data sufficiency questions, right? So if you have 37 data sufficiency questions, which means there are going to be a total of 74 statements. 74 statements is what you will have. Now I'm gonna ask you a question. The question that you should think, that out of these 74 statements, how many would be sufficient and how many would be insufficient, right? So you can clearly say that more than 60% of the statements would be insufficient in your test, and less than 60%, less than 40% would be sufficient in your test. That means we should definitely have a technique to disprove something rather than just applying the technique to prove something. So this is what generally we make mistake. We learn the technique to prove something, but we don't know the technique to disprove something. And this column method is the best thing to disprove a statement. So let's actually go and try and use that on a question. Now this says that x into y greater less than 0. Now statement 1 over here tells me that x into z is actually less than 0. So what I can do is I can actually exhaust the possibilities of x. I can say x can be a positive number, so I can pick up any number. Let's say 2 works great for me, and x can be a negative number, right? Since it's only about signs here, I should not worry about the magnitudes. It's only about positive and number being negative. You can clearly see here. Similarly, the next variable, if it's actually z, right? So if x is positive, z will have to be negative. If x is negative, z will have to be positive, right? Now this is all the possibilities. This is exhausting all the possibilities. This is making x positive, z negative, x negative, z positive. Now you can clearly see here, y can be a positive number or y can be a negative number, right? So these are the two possibilities that can happen for y. Now is x into y less than 0 here? Yes. But is x into y less than 0 here? No, right? So I don't need to even consider this column. Even only this column gives me the different values for x and y, which means what? That means this statement is not sufficient. My answer option would be either B, either C, or either E, right? So this is ADBC approach that you'll get from the first video on data sufficiency. Second statement, again, it says z into y is greater than 0. We explore all the possibilities. Z can be a positive number or z can be a negative number, and y can be a positive number, sorry, a negative number, and y can be over here it says z into y has to be greater than 0. So if z is positive, y will have to be positive. If z is negative, y will have to be negative, right? Now again, with the same logic that we used in the first statement, that x can hold any sign, that means this statement is also not sufficient. But when I combine both the statements, I see that if z is positive, x will have to be negative, right? So if z is positive, x will have to be negative. If z is negative, x will have to be positive. So from here, no matter what signs I choose, I will always get x into y to be less than 0. Which means what? By combining, I'm getting my answer. Hence my answer is option C. Right? So this is a very easy question that I've done with you using the column method. This is just, I'm just getting warmed up here. So suppose you've understood this question, what did I do over here was, I just looked at all the different possibilities of x and y. So for all different possibility of x, so what you do is in this column method is, you fix one column according to you, and the next all other columns keep on emerging from your these values, and that's how when you reach your last column, which actually matches your question stem there, you will get different possibilities. Once you have two different possibilities, that is, he's asking, is x into y less than 0? Yes, x into y is less than 0. No, x into y is not less than 0. That is giving you a yes and a no, which means what? The statement is insufficient. It is giving me a maybe. Right? So if you watch the data sufficiency 2 video in which we discuss yes no data sufficiency, I suppose this must be understood that if we get a yes and if we get a no, the statement is insufficient. Right? So let's move forward and apply this technique on another question. Now this is a very tough question when it comes to GMAT. Now it says that in which quadrant of the coordinate plane does the point xy lie? Right? So it's again asking me the signs of x and y. Is asking me what is x? Is it a positive number or a negative number? And what is y? Is it a positive number or is it a negative number? Now again, let me get different variations of x and y in terms of positive and in terms of negative. So x can be a positive number and x can be a positive number, plus 2 plus 2 minus 2 minus 2, and plus 2 minus 2 plus 2 minus 2. This way I will be able to generate all different possibilities of x and y, because x and y are independent of each other. By deciding x, I cannot decide y. That's why there will be 4 possibilities arising. So I suppose if you've done binary table in your high school, you always used to do plus plus minus minus plus minus plus minus. That takes care of all the possibilities. Now I have so many things to take care of. I have x into y to take care of. Right? So this is gonna be 4 here, this is gonna be minus 4, this is gonna be minus 4, and this is gonna be 4. Then I have x into modulus y to calculate, which is going to be 4 here and 4 here and minus 4 here and minus 4 here. Similarly, I have modulus of x into y to take care of. This becomes 4, this becomes minus 4, this becomes 4, and this again becomes minus 4. And the last thing that is there is modulus of x into y, which is always equal to 4 no matter what happens. Now the statement is saying the sum of all these 4 columns has to be greater than 0. Right? If the values which are meeting this fact, if they meet this fact, then only I can check what these are the signs of x and y. Now over here 4 plus 4 plus 4 plus 4 is greater than 0. That means this values passes for me to check, and these values are actually satisfying the fact. But over here it's not less than it's not greater than 0, it's not greater than 0, and it's not greater than 0. That means the only values for x and y which are satisfying are plus 2 and plus 2. That means x is also a positive number and y is also a positive number. Hence they lie in the first quadrant. right? So suppose everyone has understood the simplicity with which we have done this question, and there is no way that you would not be able to do this question. Always work in columns and always make sure that you have you're doing it in a very structured way. So if you look at statement 2, now statement 2 says that modulus of y has to be greater than minus y, which has to be greater than minus x, right? So this you can, now this is again one more thing that would definitely happen with you. People get so intimidated by the column method so that they start overusing it, right? So don't overuse this method. Don't start making columns when it is not required, right? So if you can actually interpret the statement very easily, you can, right? So it says that modulus of y is greater than minus y when it is possible. It is only possible when y is a positive number, right? So if you can clearly see, even if you make a binary table on that, it would work. You can take y to be a positive number or y to be a negative number, right? Then modulus of y will actually become 2 and 2, and minus of y will become minus 2 and plus 2. You can clearly see a greater than sign is here. That means this is eliminated, right? That means y is definitely a positive number, right? And similarly, if you can clearly see over here that if minus y is greater than minus x, that means y is less than x. If y is a positive number, x will also be a positive number because x is greater than y. Similarly, again, x is also positive and y is also positive, and it is lying again in the first quadrant, right? So suppose everyone has understood this question, right? So again, the answer option over here is D. When the answer option is D, make sure you check that both the statements are giving you the same value or not. It's giving you the same value. The values are lying in the first quadrant, which actually double checks my answer, right? So suppose everyone has understood this. What did I do over here in the first statement? It's just that I looked at all different possibilities of x and y, which actually made me to conclude that the only way this can be true is both numbers being positive, right? And similarly over here, again, the binary table helped me, the column method helped me to make sure that y is only positive and x is also positive, hence they lie in the first quadrant, right? So suppose everyone has understood this question, let's move forward, right? Now again, it says that a does not equal to minus b. Now the question is saying, is a minus b upon a plus b greater than 1, right? Now again, the first statement says that a is a positive number. So if a is a positive number, that means what are different possibilities of a? Now let me introduce to you the Fantastic Four when it comes to GMAT. What are the 4 different numbers that you should always check for you to exhaust every possibility? You should be checking positive integers, you should be checking positive integers, you should be checking positive decimals, you should be checking negative integers, and you should be checking negative decimals, right? So what you can have is, you can have kind of like a political leader for every of these set. So I personally have a plus 2, I personally have a plus 0.5, I personally have a minus 2 and a minus 0.5. These are the contenders, and they actually make sure that every type of number is tested. That will make sure that I do not get the question wrong, right? So for me, these are the Fantastic Four, and right here, so you can also have your own Fantastic Four, so that is completely up to you, right? So over here it says that a is a positive number, so the only possibility for a for me is that a can be a positive integer or a can be a positive decimal, right? So these are the only 2 possibilities that a has. And similarly, b over here can be any number. B can be a negative decimal, and b can be a, let's say, a negative let's say a positive number, right? So that's that's true, right? So we haven't actually completed all the possibilities, but we can try from here and let's see whether we can get a yes or whether we can get a no. So I want a minus b here. Now over here a does not equal to minus b, so I have to adapt here. Let me say this is negative 3, right? So 2 minus 3 is going to be equal to a minus b is going to be equal to 5 here, and a plus b is going to be equal to minus 1 here. Similarly, a minus b is going to be equal to let's say minus 1.5 here, and a plus b is going to be equal to 2.5 here. And this divided by this, is that greater than 1? No. Is that greater than 1? No. Now let's see whether we can get a yes or not. Similarly over here, I haven't tried all the possibilities. One possibility would be to being a lesser than b in terms of magnitude. So I can try this to be as minus 1, right? So a minus b would actually become 3 here, but a plus b would become 1 here, and this divided by this gives me a yes. Right? So once it gives me a yes, which means what? It gives me a yes and it gives me a no, which means this statement is not sufficient. Right? Now let me try with the second statement, which says that b is a negative number. Now this is something of a jackpot here, is that you don't need to try any values. What you can do is you can actually try the values from the previous statement. Right? Now from the previous statement, b is negative here and b is negative here. And in one negative case, I am getting a no, and in another negative case, I'm getting a yes. Which means what? I'm getting a no also, I'm getting a yes also, even by using the same values for statement 2. That means statement 2 is also not sufficient, and I don't need to combine. Why don't I need to combine? Is because the same set of values that a is positive and b is negative, a is positive and b is negative, is giving me a no and it's giving me a yes, which means what? My answer is option E. I don't even need to combine at all. Right? So suppose everyone has understood why don't I need to combine, is because the same set of values are disproving A also and are disproving B also, so they would actually disprove both of them also. Right? So understand, now over here all you have to do is you can work in columns and you can keep having all the possibilities, right? So you can keep exploring possibilities. Again, understand plus 2 and minus 4 wouldn't have worked here, would actually be redundantly using this possibility. So the table method actually exhausts all the possibilities and makes sure that you have tried everything before you reach to a conclusion. Right? So suppose everyone has understood this question. Let's move forward. Okay. Alright. Now the ultimate tool is that you being adaptive. Now let's suppose I say that x, the statement 1 says that x over here is greater than y. Right? So if you're choosing the values of x and y, if you choose x to be a positive number, a negative number, a positive decimal, and let's say a negative decimal, and you want to choose an appropriate value for y. Now always x is greater than y, so you can always have a number lesser than 2 here. You can probably have a 1. Over here again you should have a negative number. Over here you should have a negative, a positive decimal which is lesser than this, right? And again over here you should have a number which is lesser than this, so that you actually respect the statement, because this is a fact that you have to meet, and your table should be framed in such a way so that it actually meets this fact and gives you enough possibilities so that you can get a yes and so that you can get a no in your question. Right? So this is the ultimate tool which will actually solve all the tough questions within 2 minutes very easily. So let me show you that tool when it comes to GMAT. Now over here it says that a over here is a positive number. Now it's saying that is 1 over a plus b less than 1 over a plus b. Now the statement 1 is telling that a plus b is greater than 0. Now let me pick up the values for a and b in such a way such that a plus b is greater than 0. You know what? I will go with my famous 5. I can say a can be a positive number, right? A can be a negative number, a can be a positive fraction, and a can be a negative fraction. Similarly, if I want to keep a plus b greater than 0, if this is plus 2, for me to make this greater than 0, I can have this to be equal to, let's say, minus 1, right? Over here, it's minus 2, so I'm just randomly choosing. I'm not using any science behind it. I just want to make a plus b greater than 0. So this can be, let's say, plus 3. This can be, let's say, plus 1, right? And this can be again plus 1, right? So which is the case here, right? In every case a plus b is greater than 0. Now let's see whether we meet this condition or not. What is a 1 divided by, okay, we just have to calculate 1 divided by a plus b. 1 divided by a plus b is 1 by 1 here, this is 1 by 1 here, this is 1 by 1.5, and this is 1 by 0.5. Now what is 1 by a here? 1 by a is 1 by 2, and this is negative 1 by 2, and this is 2, and this is negative 2. Now what is b? B is already here, so I'll just repeat the column here. That is minus 1, plus 3, plus 1, and plus 1. Now the question is saying this plus this has to be greater than this. Let's see whether we get that. Is this plus this greater than this? No. Is this plus this greater than this? Yes, right? Because 1 minus 1 by 2, it's not greater than 1. So that means I have a no, I have a yes. I don't need to even check that, but I will just check that again. This plus this greater than this? Definitely yes. This plus this greater than this? That is definitely a no. So I have a lot of yeses and a lot of no's. That means this statement is definitely not sufficient. Now when I pick up my statement 2, it says a greater than 0. That means let me pick up the values where a is greater than 0 in this table. That will actually help me to reach to a conclusion. Now this over here is a is greater than 0, right? And this over here, it says that a is greater than 0, right? So this over here, it says that a is greater than 0. That is a is 0.5 and b was 1, which actually made a plus b greater than 0. So 1 over a plus b was 1 over 1.5. 1 over a was 2, and when I added plus 1 to it, so that it actually became 3. So it gives me a yes, right? So it gives me that this plus this is actually greater than this. But when I pick up these values, a is equal to 2, b is equal to minus 1. So 2 minus 1 is 1 by 1, and a plus b is greater than 0, which is fine by me. And yeah, so that actually makes that, again, it gives me a no, it gives me a yes. That means even by combining it, I will not get my answer, because I'm using the same set of values, guys. I'm using the same set of values here in this statement. That means I don't need to combine it all, hence my answer is option E, right? So only if you get a no and you get a yes from the same data set, then you don't need to combine. But if you get only 2 yeses or you get only 2 no's, right, then you should actually combine the statement, and let's see whether you can get the other thing also. So that means over here I would suggest you to watch the data sufficiency 2 video in case you're confused with the yes and no's. It's very crucial that you watch that you understand what do you mean by a yes and what do you mean by a no, right? So suppose everyone has understood this question. Let's move forward. Now this question says that so let's go ahead and do this question. And this question says that is a into modulus of b greater than a square? The first statement is telling me that a is greater than b. Alright, so let's start with all the possibilities of a. A can be a positive number, a can be a negative number, a can be a positive decimal, and a can be a negative decimal, right? So let's talk about b. Now I have to make sure that a is greater than b. So if this is plus 2, I have to make a positive number here. Guys, one advice that I'll give, stay away, from 0 and 1 when you use the column. Stay away from 0 and 1 in the very beginning. Later on you should try to apply it, because 0 and 1 always make come when there are corner cases, right? So initially stay away from 0 and 1. So I would actually make this +3 and I will try to make this as +2, right? So I would not give B as +1 because I actually want something to happen here. So then this is -2. A has to be greater than B. Let's make it a smaller number. This is plus 0.5, and so let's make B a smaller number than that. Let's say again -3, and this is -0.5. let's make A another smaller number. Let's say -0.3, right? Okay, why don't we say like minus okay, why not we say, yeah, -3 is fine, no problem. Then it says that I have to find A into modulus of B. A into modulus of B is 6 here, which is -6 here, which is 3 into this, so this is 1.5 here, right? And this is -1.5, right? So what is A square? A square comes down to be equal to 9 here, right? Similarly, A square comes down to be equal to 4 here. A square comes down to be equal to 0.25, and A square comes down to be equal to again 0.25. Now this should be greater than this, so it's lesser here, that means it's a no. It's lesser here, again it's a no. It's a greater value here, which means it's a yes, and it's this way here, that means it's a no. That means I have a yes and I have a no. That means what? This statement is insufficient. Now my time is to make sure, let's see, when B is greater than 0. So if B is greater than 0, which is in this case, so I will actually use the same previous table, and in none of my other values I made B greater than 0. So let me try to get a yes. I already have a no. If I can actually get a yes, that means this statement would be insufficient, right? So again, B is greater than 0. So B over here, I've already tried B to be a positive number. B over here can be a positive B over here can be a positive decimal, right? So B over here can be a positive decimal, and so let me try to pick up a positive number also, right? So but A can have different variations, because now I'm just using second statement. I don't want to bring the first statement into consideration, right? So A over here can have different possibilities. So A over here can be a negative number, right? And A over here can be, let's say, a positive number also, or a positive fraction also, right? So first I'll try these two. If I get a yes, my deed is done, right? So let's move forward. So A into modulus of B. A into modulus of B will make it -1, and A into modulus of B will actually make it, so A into modulus of B, that is 1/2, into B, that is again makes it 1. So then it's A square here, so A square is 4 here, and A square is 0.25, right? So the sign was supposed to be this, but the sign is actually coming this here, that means it's a no. But the sign is coming this here, that means it's a yes. So I have a yes and I have a no, which means what? This statement is also insufficient. Now I combine. Now this is some piece of information that I would like to give you. Whenever you are combining the statements, what happens is your answer option is either C or E. So understand, most of the times, like roughly 70 to 80% of the times is going to be C, and very rarely it is going to be E. That means when you combine the statements, your approach should be to use algebra rather than numbers. That should be your approach, because numbers is disproving and algebra is proving. I think we have discussed that you use numbers to disprove something, right? So you use numbers to disprove something, but when you want to prove something, you use algebra. So now your objective should be to actually try to logically think out the question, right? So now one advice that I would give you is write down all the piece of information you have. You have A greater than B, and you have B greater than 0. So if B is greater than 0 and A is greater than B, that means A will also be greater than 0, right? So if A is greater than 0, now the question is asking, is a into modulus of b greater than a square. Now if a is greater than 0, you can actually cut this to be equal to a. Now the question is asking that is b greater than a. But the first statement is telling you, you know what, a is greater than b. It actually completely negates that. That means the statement is sufficient. Hence, by combining my answer, I'm getting, that means my answer is option C. I'm going to repeat that last part once again. Whenever you're combining, understand that mostly the answer option is C. Mostly you get the answer by combining the statements. So your approach should be to use algebra here to logically think out the question, right? So if A is greater than B and B is greater than 0, if B is a positive number and A is greater than B, A will have to be a positive number. And it's asking, is this into this greater than this square? So a and a cancels out because they are positive numbers, and modulus of positive is the same number. Now the question is asking, is b greater than a? But the first statement is telling no, a is greater than b. That means I'm getting a complete no every time. Hence this statement is sufficient by combining both the answers. Hence my answer is C, which is also matching this fact. This values actually meet the first criteria and the second criteria as well, and gives me a no, which may actually double checks my answer as well, right? So suppose you've understood the question, you know, the simplicity with which we are doing. We're not using any Superman algebra here or anything like that. We're just using basic stuff and, you know, getting these tough questions out of the closet, right? So let's go ahead and do this question also. Now it says that the question is asking, is a greater than 1? Now the first statement says that a plus 1 into modulus of a minus 1 greater than 0. So let's actually get all the different variations of a. Now this becomes very easy. A can be plus 2, a can be minus 2, a can be plus 0.5, and a can be minus 0.5, right? So what would be a plus 1? So a plus 1 would be 3 minus 1, 1.5, and 1, right? So that is the case. And what would be modulus of a minus 1? Modulus of a minus 1 would be 1, again 1, again minus 0.5, and again minus 0.5, right? So is this into this greater than 0? Over here, let's say yes, this into this is greater than 0. That means this value qualifies for me to check back over here, that is a greater than 1. Understand, never confuse the fact with the statement. This is the fact which you have to meet. Now this is actually satisfying. Now is a greater than 1? Yes, it is. But this is not even satisfying the fact. That means this is ruled out. Again this is ruled out. Again this is ruled out. That means the only possibility of a is being a number greater than 1. Right? Because I've actually exhausted all the possibilities of a. I try to make a negative integer. I try to make a positive decimal. I try to make a negative decimal. That means now is the time for you to logically think out this statement, because I'm only getting a yes. Now if you can clearly see a plus 1 into modulus of a minus 1. If a is a decimal, then this becomes negative. If a is a negative number, then this becomes negative, right? So that means what? A has to be a number greater than 1, so which is what the question is asking. Hence statement 1 is sufficient. That means answer option A or answer option D. My eeny meeny miny mo, that is flipping a coin, goes to 50%. Right? Second statement says that modulus of a is greater than 5, which actually says that a can be greater than 5 or it can be less than minus 5, right? So a can be minus 7 as well, and a can be 7 as well, which is actually giving me a no, and which is actually giving me a yes when I go back and check whether it's a greater than 1. Hence this is not sufficient. Hence my answer is option A. Right? So suppose you've understood this question. Again, I suppose you're understanding the binary table here, how it works out, right? So let's see this again. Now it's the question over here is telling me that is x plus y greater than 0. Okay, so it's x plus y positive or not. The first statement is saying that x minus y is greater than 0, right? So I will actually look out for the possibilities of x and y. Now I know that it's all about being signs, right? So x can be plus 2 or plus 2 or minus 2 or minus 2. Now I have to adapt according to y so that meet this fact. X minus y has to be greater than 0. So over here I can take as x, so I don't want y to be 1, so let me make it 3 and let me make it minus minus 2. So x minus y is actually greater than 0, right? So, oh sorry, let's make it plus 2. X minus y is greater than 0 because I want to keep it plus. Now y has to be minus. Plus minus plus minus. So over here again let me make this plus 3, let me make this minus 2. Understand guys, you have to be adaptive every single time, right? So this is minus 3, minus 2, I can make it as plus 3, and understand that both the numbers can never over here I can make it as minus 3, that is minus 2 minus 3 is greater than 0. So I have all the different possible positive negative combinations for x and y. Let's see what is x plus y. X plus y is 5 here, x plus y is 1 here, x plus y is 1 here, but x plus y is minus 5 here. I have a yes, I have a yes, I have a yes, but I have a no. Right? So you see the subtleness of the question, that only one possibility is giving you the answer, right? So that means over here my answer is, the statement is insufficient because I'm getting a yes and I'm getting a no. Now the second statement over here tells me that, let me just adjust it out. The second statement says that x square has to be greater than y square. Now we gotta check it. Is x square greater than y square here? Yes. Is x square greater than y square here? Yes. Is x square greater than y square here? No. Is x square greater than y square here? No. That means I'm getting yes by using the same data set. Let me try if I can get a no from this data set or not, right? So first I won't think about combining, I'll just try to use this only. Now x square is greater than y square. Again, what are the different possibilities that x can take? X can be positive, x can be positive, x can be negative, x can be negative, right? And similarly y over here. So if x is, let's say, positive 3, I want to make y positive, so let's make it positive 2, right? And over here it says that x square is greater than y square. So if x is, let's say, positive 3, I want to make y negative, so again negative 2, right? Again it says x square greater than y square, so if I want to make x to be as minus 3, and I can make y to be as positive 2, and if this is minus 3, I can make this as negative 2, right? Again, meeting all the possibilities. Now what is x plus y here? Now this is actually, all these values are meeting the fact. So what is x plus y? 5. What is x plus y? 1. What is x plus y? Minus 1. And this is minus 5. Again giving me yes, yes, no, no, which means what? The statement is also insufficient. Now I need to combine. And do you remember what was the advice that I told you that you need to combine? That whenever it's down to C or E, whenever you're combining, logically think out the question. Okay, now it says that x square is greater than y square and x is greater than y, right? So if x square is greater than y square and x is greater than y, which actually makes sure that these both numbers are actually x over here is definitely a positive number. This actually makes sure that, because this is something that you can deduce from here. The only values that is satisfying over here, that is x being positive, which is satisfying both the facts here, right? Because why is that? Because x square is greater than y square and x is greater than y. The only possibility that you have is that x has to be a positive number. Now y over here can be a negative number also, which actually, and y over here can be a positive number also, because x square is greater than y square, so y can be a negative number and y can be a positive number. But you can clearly see that since x square is greater than y square, and that means the magnitude of x is greater than the magnitude of y. If I talk about the absolute values, that means x plus y will always be greater than 0. Hence by combining I'm getting my answer. right? So suppose you've understood this question, that over here what did we do, that it says that x is greater than y, and so even if I want to meet the facts, right? So even if over here I want to meet this fact, you can say, is x greater than y here? No. Is x greater than y here? No. You can clearly say, is x square greater than y square here? No. Is x square greater than y square here? No. You can clearly see I'm only left with yeses, right? Even if I meet both the facts. We have actually tried out everything, right? So again, that means what? This statement will not be will be sufficient when I combine both the answers, hence my answer is option C, right? So the only thing left over here for you to check, even if you want to check, is decimals, right? So if I actually want to try out decimals and make sure it meets both the fact, so x is greater than y and x square is greater than y square, so which will not be possible at all, because if I, let's suppose, pick up x to be equal to 0.5, or let's say y to be equal to 0.4, so x is equal to, x square would be 0.25 and y square would be equal to 0.16. So it's meeting all the facts, so that's fine. But if I make again x to be equal to 0.5 and y to be equal to minus 0.4, again it's the decimals play no role here at all, that you should be able to understand. The decimals play no role at all. X plus y will always be greater than 0, hence my answer is option C, right? So suppose you've understood this. If there's any query in any of these questions, just do send me a feedback, right? Do send me that you haven't understood that or not, right? So in the end, what to do when it comes to inequality questions, right? So what to do, what is the basic thing that you have to do when it comes to GMAT or CAT inequality? The first thing is start the question with numbers, right? So start the question with numbers, which is the best thing to do. What will happen is you will be able to eliminate all the obvious errors out of the question, right? So make sure you exhaust all the possibilities. You have seen that in this video only, I'd used so many columns, right? So many different types of columns. Sometimes I use plus 2, minus 2, minus 2, and sometimes I use plus 2, minus 2, plus 0.5 and minus 0.5. Now this is something that I used because in relation of another variable, because I wanted all the possibilities of plus and minus of a and b, but over here I wanted different variations of an individual variable, right? So that actually helped me to make sure that I am having different variations, right? So this actually exhausts all the possibilities, which gives you a yes and gives you a no. And when you look at the second statement, always try to use the same values as in the first statement, and if you get a yes and you get a no, you get lucky. The answer option straight away is E, right? But when the first statement is only giving you a yes by combining with the second one, or only giving you a no, so then you try to disprove the second one, right? Again with the same case, and if you're not able to disprove an individual statement, right, so then is the time to logically think out the statement, right? So then is the time that you should logically think out. Now understand, initially if you start to think out the question logically in the very beginning without using numbers, you'll have so many variations to think of. You know what, this can be possible, or this can be possible, or this can be possible. But when you actually rule out all the obvious one and you say why x is coming greater than y, that means that actually helps you to channelize your approach. That actually helps you to make sure that you are going in the right direction. And understand, you will never fail if you become an expert in this technique. You will never fail in inequality questions. And when you combine, when it is about answer option C or answer option E, always try to logically think out the question, because mostly it is C. Very rarely it will be E when you're combining the statements, right? So 60 to 70% of the times it will be C. So try to logically think out the questions, right? So these are the two things, right? So one is using numbers and one is trying to logically think out the question. This is only used to disprove things, and this is only used to prove things, right? So I suppose you've understood this question, right? So you've understood this technique. Thank you very much for watching the video, right? So this is our Facebook page where you can like us, right? So make sure you do that. This is to explore the world of perfect scores, and don't forget to send me your valuable feedback. So this was the second video wherein we learned the column method. Now understand, the column method is an art, right? It's completely an art that you will have to develop. Though I try to make it as much science as possible, but still it always remains an art. It always remains as something that it will be completely subjective to your personality, right? So make sure that you develop this art through practice, right? So this was about the video, guys. Thank you very much, and I'll see you in the next video.